Hello students, I welcome you in today's session of physics, and in physics we are going to discuss your chapter number 7, which is called electricity and magnetism. You can see here this is the chapter we are taking right now. So in this chapter first we talk about laws of magnetism. We have studied the rules of magnetism in previous class, so let's recall the laws of magnetism in brief here. First one, a freely suspended bar magnet always come to rest along the north-south direction. You can see here, if you suspend a bar magnet with the help of a thread, then it always rests in the north-south direction. Here the end point of the magnet that point towards the north is called your north pole, and the magnets at the end point toward the south is called your south pole. Fine. The second one, like poles of the magnet repel each other, while unlike poles attract each other. So if we bring the north pole of a magnet near the north pole of a freely suspended magnet, the pole of the magnets repel. But if we bring the north pole of a magnet near the south pole of a freely suspended magnet, then the pole of the magnets attract. So from this derivations or experiments, we can say that the like poles repel each other and unlike poles attract each other. Fine. You can see this experiment number 7.2. From this experiment you can say that here it is given that. Now you can see here experiment the third one. We will talk about the third point. The pole exists in pairs. The poles of the magnet always exist in pair. You can see here there is a south and the north pole. If we take bar magnet and cut into two pieces, now what happens if we divide a single bar magnet into two pieces? Are the pole still exist? Yes. The answer is yes. The south and north pole is still exists. So the two new magnets will have the north and the south poles. If we again divide these two magnets, then what happens? The poles are still there. So the reason you can say that we can never isolate poles from the magnets from this figure 7.3. So that is the thing written here. We will have their own north and south pole, means every magnet have their own north and south pole. So a magnet always has two poles. It is important to note that we never isolates the north pole of a bar magnet from its south pole. Clear? As I shown you in figure number 7.3. The magnetic strength is maximum at the poles of the magnet. This is important line. You should ask where the magnetic strength of the magnet is very stronger. So the answer is it is stronger at the poles of the magnet. Now we will come to repulsion, a sure test of magnetism. So a magnet can attract the opposite pole of other magnet as well, the magnetic substances like iron, cobalt, nickel. So if a magnet attracts another object, we cannot say that the other object is a magnet, but if the magnet repel the object, then we surely say that the other object is a magnet, because like pole of a magnet repel each other. Now we will come to what is electromagnetism. This is important, so kindly remember this. What is electromagnetism? The magnetic effect of current was discovered by the scientist Oersted in 1820. Oersted found that a wire carrying current was able to deflect a compass needle. Now the compass needle is a tiny magnet which can deflect only by the magnetic field. Fine. Here you can see this is the compass needle. Since a current carrying wire was able to deflect a compass needle, so it was concluded that a current flowing in a wire always gives rise to a magnetic field around it. Means a current carrying wire creates a magnetic field. That is the thing written here. The importance of magnetic effect of current lies in the fact that it gives rise to a mechanical forces. The electric motor, electric generator, telephones and radios all utilizes the electric effect of current. The magnetic effect of current is also called electromagnetism, which means electricity produces magnetism. Clear? Now there is an experiment given here to demonstrate the magnetic effect of current, means how the current carrying wire creates the magnetic effect. So we will now describe the Oersted experiment to show that the current carrying wire produces a magnetic effect. Here you can see that we are now going to discuss the Oersted experiment. So we take a thick insulated copper wire and fix in such a way that the position AB of the wire is in the north-south direction. Here you can see this is the experiment we are talking about, this one. A plotting compass M is placed under the wire AB. The two ends of the wire are connected. Here we connected the wire through a battery, and this one, throw a switch which when no current is flowing in the wire AB, the compass needle is parallel to the wire AB. You can see here from this figure 7.4a. You can see there is no deflection in the needle because the switch is open here. So the needle is in normal position. Now what happen if we connect the switch from 7.4b? You can see that as soon as you press the key or completed the circuit, the needle of the compass starts showing the deflections. Fine. So finally, what the conclusion? You can say that as soon as the circuit is complete, the current in the wire starts showing the magnetic property. That's why the magnetic needle of the compass showing the deflections. So let us pass. That is the thing written over here in the complete experiment. The whole experiment is described here, and I already described you in a very brief. So now we will move to electromagnet. What is electromagnet? So a magnet formed due to the passage of electric current. Clear? What is electromagnet? A magnet which is formed due to the passage of electric current and retain its magnetism as long as the current passes through it. It is known as an electromagnet. Fine. It is a temporary magnet that works on the magnetic effect of current. You have to remember on which principle the electromagnet works. So it also works on the magnetic effect of current. The arrangement of electromagnet requires a long coil of insulated copper wire wound on a soft iron core. So when the two ends of the coil are connected to a battery, it works as a magnet. I will show you the figure also. You can see here, this is the figure of electromagnet. Fine, this one. So as soon as the current in the coil is switched off, what happens? The soft iron core loses its magnetism. This is the important line. You should know why the iron is always used in place of electromagnet, or which material we use to for making an electromagnet. So you have to give the answer that iron is used as a material for making electromagnet. Now again the question arises, why we use only iron? Because of as soon as you switch off the current in the electromagnet, the iron has a property to loses all its magnetism. That's why we prefer iron instead of other materials. So electromagnet can vary in their shapes and sizes depending upon the purpose for which they are to be used. The strength of the electromagnet highly depends on the magnitude of electric current passes through it. As the stronger the current you pass through the electromagnet, the stronger is the electromagnet. Clear? The magnetism of electromagnet remains as long as the current flowing in its coil. Till you pass current through the coil of the electromagnet behaves like a magnetic or electromagnet. So as soon if we press switch off the current in the coil by opening the switch, all the magnetism of the iron rod disappear and it no longer behave as a magnet. So we can now define an electromagnet as follow. From here you can say that an electromagnet is a magnet consisting of a coil of insulated wires wrapped around a piece of iron that is magnetized only when the electric current is passed through the coil. Fine. So please note that this is the thing I already told you why we use iron as a material for making an electromagnet. So I am skipping this. Now we will come to what is advantage of electromagnet over permanent magnet. This is important one. So an electromagnet is a temporary magnet because its magnetism is only for the duration of current. Means as soon as you pass the current, then it acquires the property of magnetism. Actually, an electromagnet is better than a permanent magnet in many respects. So some of the advantages of electromagnet over the permanent magnet are as follows. The first one is the magnetism of an electromagnet can be switched on or switched off as desired. This is only possible with a permanent. This is not possible with a permanent magnet. Fine. So this is the first advantage. Now we will talk about what is the second advantage. An electromagnet can be made very strong by increasing the number of turns in the coil. Fine. Now the second one, by increasing the current passing through the coil. On the other hand, a permanent magnet cannot be made so strong. Clear? Another advantages of electromagnet, you can see here, electromagnet can be easily magnetized or demagnetized by turning on or off the current respectively. We can make a stronger electromagnet than any other permanent magnet. By reversing the duration of current, we can reverse the pose of an electromagnet. Fine. Now we will talk about here applications of electromagnet. What are the applications? So some of the important uses or applications of electromagnets are as follow. Electromagnets are used for lifting heavy loads like big iron machines, steel grinders and scrap iron objects for loading and unloading purpose. The second one, electromagnets are used for separation of iron and steel object from a heap of metal scrap. Means if there is a multiple metals present there, so you can easily isolate iron from that scrap. Electromagnets are also used for making large number of electrical devices like electric bells, fine, loudspeakers, electric motors, electric fans and telephone instruments, etc. So here you can see we are going to discuss now what is electric bell, this one. So electric bell works on the magnetic effect of current. This is important one, you always know on which principle is electric bell works. So it has an electromagnet in it. The electric bell uses an electromagnet to pull that clapper onto a magnetic bell called gong. The clapper of the electric bell is also known as hammer. We will now describe the construction and the working of an electromagnet in detail. You can see here the working of construction of electric bell. You can see this figure, this is the whole diagram of electric bell, this one. This one is your gong and this is called the hammer. This is your electromagnet, the U-shaped electromagnet, and we connect through a battery, fine. So what is the working or construction? You can see here the electric bell has a U shape, as I already show you, electromagnet, fine. A small iron bar A called armature is held in front of the poles of the electromagnet. This is, you can see here, this is your armature, this one, this is your armature, fine. The lower end of iron bar is attached to a flat spring S and the flat spring S is itself fixed to a metal bracket B. The upper end of iron has a clapper C attached to it. Initially, when the bell is not working, the clapper C is at a short distance away from the gong G. There is a contact screw D which just touches the iron bar A at point where E. The contact screw D is also called the interrupter because it interrupts or breaks the circuit of electric bell periodically. A metal gong capital G, which is a hollow like a bicycle bell, here you can see this is the gong, is fixed near the clapper. The bell works with a battery T and push a button, fine. Now you can see here in the below section, switch P is provided to ring the bell. We will now describe the circuit of the bell. The end of the electromagnet coil is connected to one terminal of the battery as shown in the above figure, and the other end of the coil is connected to the B carrying the iron bar or armature. The other terminal of the battery is connected to the contact screw 2 through the push button P. So working of electric bell, in order to ring the bell we press the push button or switch P, fine. So when we press the switch, the electric circuit of the bell is completed and the current passes through the coil of the electromagnet and it gets magnetized. The electromagnet attracts the iron armature A towards itself. As the armature moves towards the poles of the electromagnet, the clapper C attached to strike the gong and produces a ringing sound. We say that the bell is ringing. Now when the armature A moves towards the magnet, its contact with the screw D is broken at point E. Due to this, the electric circuit breaks and no current flow in the electromagnet coil. So when there is no current in the electromagnet coil, so all electromagnet loses its all magnetism for a moment and the armature is no longer attracted by it. The flat spring S bring back to the iron armature to its original position and the clapper also move away from the gong. As soon as the armature comes back and touches the contact screw E, the circuit is completed and the current starts flowing in the electromagnet coil again, fine. So the electromagnet attracts the iron armature once again and the clapper strikes the gong again, producing a ringing sound. This process of make and break of the electric circuit continue as long as we press the switch. So due to this, the armature vibrate forward and backward rapidly each time, making the clapper strike the gong. Thus the clapper strike the gong rapidly, producing almost continuous sound, and we say that the bell is ringing. I hope you understand it. Now we will discuss about what is electricity. Clear? So electricity play a vital role in our day-to-day life. It is one of the most important useful form of energy. It is used for many purposes like heating and cooling of our rooms, cooking foods, running refrigerator, etc. Clear? So you can see here we connect a bulb across a circuit. This is a given circuit and we connect a bulb. Its filament is heating. So electric is a form of energy that exists as the charge in all atoms. There are two types of charges. First one is a positive and the other one is negative charge. So electric current is always caused by the particle called electrons that carry negative charge. When these charges stay on an object, it is known as static electricity, whereas moving charges constitute electric current or simply electricity. Generally, metal contain loosely bound electron in their outermost orbits. Fine. So the electron moves randomly in all directions when these free electrons are made to flow in a particular direction. It is called electricity. So the amount of charge flowing per unit time is known as current. The SI unit of charge is coulomb and the SI unit of electric current is ampere. So I is equals to, your term is Q by T. This is the relation of electric current, rate of flow of charge in unit time. Clear? You can see this formula. This is the formula for electric current. Current equals to Q by T. So though electricity is very useful, but it can also be very dangerous. If electric wires and electrical appliances are handled properly, then a person gets electric shock. We should never use electricity for power points in our homes or school for performing science experiment because it is very unsafe and dangerous to do so. We will now describe a safe source of electricity which we can use for our study of electricity by performing experiments. We can use an electric cell to get electricity that is safe for performing experiment. Please note that an electric cell is commonly known as a dry cell. Clear? A cell provides much less electricity than the provided by power stations. For example, a single cell usually provides how much? 1.5 volt of electricity, whereas the electricity which comes from the power station consists of 220 volts. In order to get electricity from a cell or a battery, we have to connect into a circuit. We will discuss this in detail for a while. So that's all for the today's class, student. In our next topic, which is your electric cell, we will discuss in our upcoming lecture number 2. Fine. Till that, do study. Thank you, class. Thank you very much.